Aldehyde. Aldehyde contains the carbonyl group, a group in which a carbon atom has a double bond to oxygen. The carbonyl group in aldehyde is bonded to at least one hydrogen atom. Using R, we can designate the general formula as RCHO. R stands for alkyl or aryl, or H. What is alkyl? An alkyl is a functional group of an organic chemical that contains only carbon and hydrogen atoms which are arranged in a chain. Example of alkyl is methyl. The substituent of methyl is CH3 derived from methane. Next example is the butyl. The substituent is the C2H5 derived from the butene. What is aryl? Aryl is any functional group or substituents derived from an aromatic ring, usually an aromatic hydrocarbon such as phenyl and naphthanol. This is the structure of phenyl group. The general formula is C6H5. Next is the naphthanol group. The general formula is C10H8. Aliphatic and aromatic aldehydes. What is aliphatic aldehydes? Aliphatic aldehydes, number 1, the aldehydes in which the aldehydic functional group, open parenthesis, negative CHO, close parenthesis, is attached to a saturated carbon chain are called aliphatic aldehydes. Number 2, their general formula is CnH2n plus 2. Example of aliphatic aldehydes. First is the pentanal. The main chain is the pentane. Drop the letter E and change to Al. Next is the heptanal. The main chain is derived from the word heptane. Drop the letter E and change to Al. What is aromatic aldehydes? An aromatic aldehyde is defined as an amalgam containing the CHO radical, such as benzaldehyde, which has an odor profile reminiscent of almonds. Generally speaking, these chemical compounds provide a soapy, waxy, lemony, floral touch to a perfume formula. Example of aromatic aldehydes. First example is the benzaldehyde. The formula is C6H5CHO. Second is the phenylethanone. The formula is C8H8O.
Preparation of aldehyde. Oxidation of primary alcohol. General formula: R bonded to CH2OH, which is primary alcohol, will added to oxidizing agent and will be formed aldehyde. And also primary alcohol will added a strong oxidizing agent and it will be formed carboxylic acid. Primary alcohol can be oxidized to either aldehydes or carboxylic acid. First, oxidation of primary alcohol to form aldehyde. Here the example using PCC as oxidizing agent. Primary alcohol, which is R bond to CH2OH using oxidizing agent, which is PCC or pyridinium chlorochromate with CH2Cl2 or dichloromethane, a solvent substance that needs for the reaction. So the product of this reaction is aldehyde. Next, using a strong oxidizing agent to form carboxylic acid. For example, ethanol or CH3CH2OH added a strong oxidizing agent, which is H2CrO4 or chromic acid with acetone in 35 degrees Celsius. It will become ethanoic acid or CH3 bonded to carbon with double bond of oxygen and bonded to OH. Another strong oxidizing agent, ethanol added KMnO4H plus or potassium permanganate with using heat, a triangle shape below the chemical equation, and this will become a carboxylic acid called ethanoic acid. Naming of aldehydes. IUPAC rules for naming aldehydes. First, to establish the parent name, select the longest continuous chain of carbon atoms that contains the aldehyde group. An example of aldehyde compound. So this is the parent chain. Second, the carbons of the parent chain are numbered starting with the aldehyde group. Since the aldehyde group is at the beginning or end of a chain, it understood to be 1. Example. Third, form the parent aldehyde name by dropping the E from the corresponding alkene name and adding the suffix -al. And last, other groups attached to the parent chain are named and numbered as we have done before. Since it has 4 carbons, it is called butane. Dropping the E and adding the suffix -al. And it has methyl attached the parent chain, which is located in the 3rd carbon, and that is 3-methyl. So the final name is 3-methyl-butanol.
Aldehydes are named by replacing the final E of the name of the corresponding alkane with EL. The aldehyde group is always carbon 1 and need not to be numbered. IUPAC, methanol, ethanol, and propanol. The common name of methanol is formaldehyde. The common name of ethanol is acetaldehyde. The common name of propanol is propionaldehyde. Methanol is also known in common name formaldehyde. Methanol is the first member of the aldehyde family. It has 1 carbon atom, 2 hydrogen atoms, and 1 oxygen atom. Its chemical formula can also be written as CH2O. In ethanol or acetaldehyde, there are 2 carbons present. One is the carbonyl carbon, and the other is carbon present in the methyl group. The carbonyl carbon is attached to the oxygen by a double bond, with the hydrogen by a single bond, and with the methyl group is a single bond. Propionaldehyde or propanol is the organic compound which the formula CH3, CH2, and CHO. It is the 3rd carbonaldehyde. It is the colorless, flammable liquid with a slightly fruity odor. It is produced on a large scale industrially. 2.1 IUPAC names. Aldehyde functional groups bonded to a ring are named using the suffix carbaldehyde. Benzaldehyde is used more commonly than the name benzene carbaldehyde. IUPAC names: benzene carbaldehyde, cyclohexane carbaldehyde, 2-naphthalene carbaldehyde. Common name: benzaldehyde.
2.2 Common names. Aldehydes are named from the common names of the corresponding carboxylic acid. The IC acid ending is replaced with aldehyde. The general formula of formic acid is SCO2H. The IUPAC name of formic acid or symbol HCO2H is methanoic acid. The general formula of propionic acid is CH3CH2CO2H. The IUPAC name of propionic acid or symbol CH3CH2CO2H is propanioic acid. The general formula of butyric acid is H
Reaction of aldehyde: oxidation, acid, reduction, alcohol. Examples: ethanol react to ethanol. Vinaldehyde react vinyl alcohol. Reaction of aldehydes: biological oxidation reduction reaction, and they are carried out in the body by substances called coenzymes. One coenzyme is NAD or nicotinamide adenine dinucleotide. Other example of organic compounds is the word ketones. If two alkyl groups are attached to the carbonyl group, the compound is known as ketones.
General formula of ketones: CnH2nO. Here are the physical properties of ketones. Number 1, it has a colorless liquid. Second, higher members of being solid. And third, a pleasant smell. And this is the reduction of ketones. Oxidation of ketones. Ketones are not oxidized under these conditions as they lack the critical H for the elimination to occur. Ketones are generally oxidized under vigorous conditions, strong oxidizing agent, and at elevated temperature. The oxidation of ketones involves carbon-carbon bond cleavage, resulting in a mixture of carboxylic acids having lesser amount of carbon atoms than the parent ketone.
Preparation of ketones by oxidation of secondary alcohols. Here is the example. Nomenclature for ketones. Assigning the IUPAC names to ketone is similar to naming aldehydes except that the ending 1 is used instead of al. The rules for IUPAC ketone nomenclature follow. Rule 1. Select as the parent chain the longest carbon chain that includes the carbon atom of the carbonyl group. Rule 2. Name the parent chain by changing the E ending of the corresponding alkene name to 1. This ending, 1 is pronounced as on. Rule 3. Number the carbon such that the carbonyl carbon atom receives the lowest possible number. The position of the carbonyl carbon atom is noted by placing a number immediately before the name of the parent chain.
Rule number 4. Determine the identity and location of any substituents and append this information to the front of the parent chain name. Rule number 5. Cyclic ketones are named by assigning the number 1 to the carbon atom of the carbonyl group. The rings is then numbered to give the lowest numbers to the atoms bearing substituent. Reactions of ketone. Addition of hydroxylamine. Ketone gives oximes with hydroxylamine. Uses: oil-based paints, suppress skinning of paints, formation of skin on paints. Reactions: addition of hydrazine. Hydrazine gives hydrazone. Uses: measuring the concentration of low molecular weight aldehydes and ketones. Medical.
Oxidation, ketones, reduction, secondary alcohol. Selected ketones whose uses are based on their odor or flavors. Clove flavoring, a popular flavor in cigarettes, oils, candy, and beer. The distinctive flavor and scent of clove has found its way into toothpaste, soap, cosmetics, and even perfumes. If you love the taste of clove, we are confident you will love Beckfront flavor, Sold World Clove flavoring. As you can see, mo na yung example sa ketones. Nya. Kung asa ang ketones, adto ta magsugod og ihap. Halimbawa, kaning CH3. 1, 2, 3 plus 4 mo nang nahimong heptanon. Nya ang to dari man dapit sa CH3 1 to mo ning nahimong to heptanon.
Butter flavoring. Artificial butter flavoring may contain the acetylpropanol or acetone. 3 natural compounds in butter that contribute to its characteristic flavor. Because of this, manufacturer or margarines or similar oil-based product typically add the acetylpropanol and acetone along with the beta-carotene for the yellow color to make the final product butter flavored because it would otherwise be relatively taste. Butter flavoring formula: CH3CCCH3. It is called butane diene. Another example, CH3, C, CH2, CH3. Find the longest chain. 5. Naming 2 and 3 pentane dione. Another example, CH3, C, CH2, C, CH3. Find the longest chain. Naming 2 and 4 pentane dione. Hemiacetal and hemiketals. What is hemiacetal? A hemiacetal is alcohol and either attached to the same carbon. The fourth bonding position is occupied by hydrogen. A hemiacetal is derived from a aldehyde. The term a hemiacetal derives from the Greek word hemi, which means half. Hemiacetal are formed.
What is hemiketals? Hemiketals are organic compounds having the structures R2C, OH, or RH derived from ketones by formal addition of an alcohol to the carbonyl group. The rings of ketose sugars are hemiketals. Hemiacetal and hemiketal formation. An aldehyde can react with an alcohol to form a hemiacetal. A ketone can react with an alcohol to form a hemiketal. Organic acids. Organic acids are acids that has a carbon skeleton. Organic compounds with acidic properties. Organic acids partially dissociate in neutral aqueous solution and are generally considered as weak acids. The three major types of Bronsted-Lowry acid are carboxylic acids, phenol, and alcohols.
Carboxylic acids. Carboxylic acids are the most common and the most acidic organic compounds, much stronger acids than water, alcohols, and phenol. This is the example of carboxylic acids. Phenols. Phenols are the most acidic than alcohols but less acidic than carboxylic acid. Phenol, pKa value of 10 to the power of negative 10. Benzene ring is electron withdrawing, so it will stabilize the phenoxide ion. This is the example of phenols. Alcohols. Alcohols are acidic in nature because it provides hydrogen ion but it is very less acidic. pKa value 10 to the power of 16 to 10 to the power of 18. Less acidic than water, 10 to the power of 7. R group is electron donating group, so it will destabilize the alkoxide ion. This is the example of alcohols.
Preparation of aldehydes. Aldehydes can be produced by the oxidation of primary alcohol using mild oxidizing agents such as KMnO4 or K2Cr2O7. As you can see, in the left side, there's a primary alcohol oxidation and the right side is aldehyde. When this reaction is used for aldehyde preparation, reaction conditions must be sufficiently mild to avoid further oxidation of the aldehyde to a carboxylic acid. Naming acids. Rule 1. If the oxyion in the acid ends in 8, change the ending to "ic", then add the word acid. Examples: HClO3, the ion is ClO3, which means chlorate. Name the acid by removing 8 and adding "ic", then add the word acid. Example: chloric acid. Another example is HClO4, the anion is ClO4, which is perchlorate. Name the acid by removing 8 and adding "ic", then add the word acid, which is perchloric acid. Naming acids. Rule 2. If the oxy ion in the acid ends in "ite," change the ending to "us." Then add the word acid. Examples: HClO, the ion is ClO, which is hypochlorite. Name the acid by removing "ite" and adding "us." Then add the word acid, which is hypochlorous acid. Example number 2.
Naming acids. Rule number 3. Naming acids formed from monatomic anion or polyatomic without oxygen with IDE ending using the following guideline. Reference A. Change the IDE ending on the anion to IC. Example for an acid made from chloride, Cl. Reference B. Add the prefix hydro to the beginning of the name. Reference C. Add the word acid to the end of the name. And now we create hydrochloric acid. And now we go to properties of organic acids. They are weak acid and B. This is the difference from concentration. You can be weak acid but very concentrated. Second verse, like alcohols, the smaller organic acid, like the example given earlier, are miscible in water. Third verse, larger organic acid are only soluble in organic solvent like alcohol or oily compounds. Fourth verse, the smaller acid are liquid at room temperature while the large one are solid. The BP increases as the number of C atom increases. Reaction of organic acids are the same as for the inorganic acid we already know. This is the organic acid. Acid plus alkyl, acid plus metal carbonate, acid plus metal hydrogen carbonate. And this is the inorganic acids: salt plus water, salt plus hydrogen, salt plus carbon dioxide plus water, salt plus CO2 plus water. And only thing that changed is the name. For example, ethanoic acid plus sodium hydroxide. In other name called sodium ethanoate plus water. Other example, methanoic acid plus potassium carbonate. In other name, potassium methanoate plus carbon dioxide plus water.
Benzoic acid. What is benzoic acid? Benzoic acid is a crystalline, white, and odorless organic acid that is widely used as a food preservative as well as in the manufacture of various products such as cosmetics, pharmaceuticals, and industrial chemicals. Benzoic acid is slightly soluble in water and also the simplest aromatic carboxylic acid. It is applied to perfume, dyes, herbicides, medicines, and insect repellents. An example of benzoic acid is lipstick. This is what benzoic acid looks like. Formula and structure. Benzoic acid is described by the chemical formula C6H5COOH, which consists carboxyl group attached to benzene ring. Its structure is already shown in the picture. History and discovery. Nostradamus first discovered benzoic acid in the 16th century and also isolated it from benzoin resin. On the other hand, in 1832, Eustace von Liebig, a French chemist who discovered that benzoic acid could be synthesized by the oxidation of benzyl alcohol and led to the production and use of the compound. If you are confused whether benzoic acid is safe or not, I have found in my research that low exposure to benzoic acid appears to be non-toxic, but consuming high amount may be poisonous. However, it would be difficult to consume so much of it in foods.
And uses. Benzoic acid is a weak acid with a pH of around 4.2 in water at room temperature. It has a melting point of 122 to 123 degrees Celsius and a boiling point of 249 degrees Celsius. It is soluble in hot water, alcohol, and ether, but only slightly soluble in cold water. Other uses. In addition to its uses in the food industry, benzoic acid is also used in the production of various other products. For example, it is used in the manufacture of certain types of plastics, such as polyesters and phenolic resins. It is also used in the production of dyes, perfume, and pharmaceuticals, including topical antifungal creams and nasal spray. In food industry, benzoic acid is often used as a food preservative due to its antimicrobial properties, as it can prevent the growth of mold, yeast, and bacteria in acidic foods such as fruit juices, soft drinks, and pickles. It is also used as a flavoring agent in certain foods, such as fruit-flavored candies and gum.
Conclusion: benzoic is a widely used organic acid with antimicrobial properties that make it a valuable food preservative. It also used in the manufacture of various other products including cosmetics, pharmaceuticals, and industrial chemicals. When benzoic acid is generally considered safe, it can cause skin irritation and other side effects at high levels. As with any chemical, it is important to use benzoic acid in accordance with good manufacturing practice and to take appropriate safety precaution when handling it. Ingesting large amount of benzoic acid can also cause side effects such as nausea, vomiting, and abdominal pain. People with asthma or other respiratory conditions may be particularly sensitive to benzoic acid fumes. Safety and side effects. Benzoic acid is generally recognized as safe or GRAS by the U.S. Food and Drug Administration or FDA when used in accordance with good manufacturing practices in cosmetics and food. So, GRAS, by the way, is to give companies a quicker or more efficient method of adding substances to their products. However, high levels of benzoic acid in food or cosmetic products can cause skin irritation, particularly in people with sensitive skin.